All right, so let's have a look at our next question from AP Calculus free response questions. And so we did question 1, so now let's have a look at question 2. Right, so it says f and g are these functions. One's a natural log function, one's a quartic function with positive leading coefficient, and we're going to try and figure out exactly what's being asked and how to answer it. So we have g of x, which is a quartic function, so that's going to be function g. F of x, which is a logarithmic function, so this will be function f. And we want to find the area of the region enclosed by the graph. So the area of the region enclosed by the graphs, right? And it says that we intersect at -2 and at b. So it's going to be integral from the left intersection, -2, to the right intersection, b. We're told that we intersect somewhere at b of our top function. All right, so that's going to be f of x minus our bottom function, that's going to be g of x dx. Okay, so that's going to be the kind of math that we do, and now we're going to have to figure out how to do that math. And so let's go ahead and bring up our calculator and see if we can make these computations. All right, so I'll come over here to my grapher. I don't need that graph anymore, so I'll go ahead and delete that function. Let's add a function. Okay, and so the first function, right, what was it? Natural log of x plus 3. So I'll have the natural log of x plus 3 inside of the parentheses. All right, so that's the first function. Next function is going to be x to the 4th power. So let's go ahead, x to the 4th power plus 2x cubed. So we've got our two functions, right? Does it tell us about an interval? Well, it doesn't quite tell us an interval, but we have an idea. We're basically looking from a little bit to the left of -2 to a little bit to the right of +1. So I'm going to go ahead and come over here and say, let me go to my graph. Right, and so there I have my graph. So I need to find an intersection. So let me go ahead and calculate my intersection. So I'm going to calculate the first intersection, which is at -2, and the second intersection seems to be at 0.7819. So we'll go ahead and write that information down. So B is equal to 0.7819. Okay, so now we want the integral of f of x minus g of x. So let's go ahead and go back home, make a computation. All right, so we want an integral from -2 up to 0.7819. Let's put this up so that we can see what we're doing here. All right, so -2 up to 0.7819. And it's going to be of my top function. So let's put on my top function, which is f of x, minus my bottom function, which in this case was g of x. And I'll go ahead and make that computation, which is about 3.603 if I truncate to 3 decimal places. So this is going to be approximately 3.603 when I truncate to decimal places. No units are given, so I'm not going to use units. All right, so h of x is going to be the vertical distance between f and g. Is h increasing or decreasing? So we know our reasoning, right, is going to be if h prime is greater than 0, then h of x is increasing. All right, so we need to figure out, right, h of x, which is going to be the vertical distance, so that'll be f of x minus g of x, right? So therefore, h prime of x is going to be f prime of x minus g prime of x. All right, and if we consider this, we want it at 0.05, all right, h prime of negative 0.5 is what we want to figure out. So let's go ahead and use our calculator to help us with that. Okay, so how are we going to do that with our calculator? We can see that it's f prime minus g prime. So I'm going to come and I'm going to calculate a derivative, and I have the derivative of f of x, and I want that calculated at negative 0.5, and I want the derivative of g of x, and I want that calculated also at negative 0.5. All right, so h prime of negative 0.5 is going to be 0.4 minus 1, which is negative 0.6. All right, so negative 0.6, so therefore we are decreasing. Okay. Then region is the base of a solid. Cross sections perpendicular are squares. So let's go ahead and say I've got this as the base of a solid perpendicular to the x-axis of squares, right? So I've got these squares that are coming up from my shape, and I know that I want to find the volume of the solid, and the volume is going to be the integral from -2 to b of my cross-sectional surface area with respect to x. So that means for us, for part C, we're going to have the integral from -2 to b. I've already said what b is. And then the cross-sectional surface area is h of x quantity squared, right? Because it's a square, and the length of a side of the square is h of x, because that's what we're told the vertical distance is. Okay, so if that's the case, and h of x is f of x minus g of x, right, we're going to go ahead and use our calculator here. All right, let's slide this over so that we can see our work a little bit better. All right, slide this up. There we go, so we can see more. So I'm looking for an integral. All right, and it's going to be from -2 to, we said, what was it, 0.7819? 0.7819. All right, and then it's going to be of, all right, our cross-sectional surface area, which is going to be our top function, minus our bottom function, which in this case was g of x. And we want that to be squared. All right, so f of x minus g of x, that quantity squared. So that gives us 5.340, it looks like. So we're going to say that that is 5.340. Then we have part D. A vertical line travels left to right along the base of the solid. The vertical line moves at a constant rate. So basically, we've got this line moving over so that eventually, right, it just kind of is going to trace out my figure as it kind of keeps on moving to the right. And let's see, what else does it say? 7 units per second. So my change in x is 7 units per second. And the rate of change of the area of the cross section. Okay, so for part D, here's what we're looking at. We know that dx dt is equal to 7. We want to figure out the rate of change of the area. We know a formula for the area with respect to x is, right, the formula with respect to x is going to be, all right, we said f of x minus g of x quantity squared. So that means that the rate of change of area with respect to time is going to be 2 times f of x minus g of x. right, to the first power times the derivative of that, which would be times f prime of x minus g prime of x. Now, we technically found, right, at negative 0.5, we technically found some of this information, right, but really it's this f prime of x minus g prime of x, but we also have, we need to do with respect to our derivative to x, so we also have a times dx dt. All right. Now, an easier way I think to think about this is to say, hey, that the rate of change of area with respect to time will be the rate of change of area with respect to x times the rate of change of x with respect to time. And so then like I said, I feel that in this form, we can see that this here is the rate of change of area with respect to x, and then we have the chain rule application of that rate of change of x with respect to time. Okay, so this part right here, we're doing it at negative 0.5. So we know that this is going to be then 2 times f of negative 0.5 minus g of negative 0.5, right? Then times, what did we find up? Negative 0.6. So then times negative 0.6 and as well multiplied by 7. Okay, so let's go ahead and get our calculator to help us with those computations. All right, let's move this over so that we can see a little bit. And so we just need to find f of negative 0.5 and g of negative 0.5. All right, so number of ways that we could do that. I could say from my variables, what is f of negative 0.5? Right, and that's 0.91629. And I could say, what is g of negative 0.5? And we have that value. And I want f minus g, and that gives me 1.10379. And I'm going to take that number and multiply it by negative 0.6, and then also multiply that number. Let's try come back. All right, multiply by negative 0.6, and then also multiply by 7. And so then that gives us that it is approximately, let's look at that value again, negative 4.6359. So we'll just truncate, and that's negative 4.635. All right, and that would be our square units. And so this would be our rate of change of the area with respect to time. So at negative 0.5, right, at negative 0.5, which negative 0.5 would be somewhere over here, right? At negative 0.5, it does seem like that distance is getting smaller. And if that distance is getting smaller, then of course the area is going to be decreasing. So those are the solution approaches. Now let's go ahead and talk to what would be the marks associated with these. So let's see if we can figure these out. So find the area enclosed. I imagine that we have a setup and an answer for this one. Increasing or decreasing, give reasoning. I imagine finding the right value and getting the correct reasoning. All right, let's see. Region enclosed, base of a solid, cross sections perpendicular. I imagine this one is setup and our answer. And the last piece in terms of marks, my predicted piece, we have a chain rule application, we have an answer application, and we have a final answer. So I would imagine that attempting the chain rule is going to be 1 mark. Having the chain rule with related rates is going to be 1 mark, and then the final answer will be 1 mark. So in other words, finding dA dx will be a mark. multiplying that by dx dt will be the second mark, and then the final answer being the third mark. And so if we have a total of 9 marks or 9 points, 1, 2, 3, 4, 5, 6, 7, 8, 9 marks that are available for this FRQ number 2. Thank you very much for your time. Hopefully the process here makes sense to you.